Hello student, today we are going to discuss about the structure of atom. So atom is basically divided into three subatomic parts that are electron, proton and neutron. So atom is divided into three subatomic particles and the name are electron, proton and neutron. Okay, so now we will discuss the various model which were described or which was proposed by different scientists to define the structure of an atom. So the first person who told about the structure of atom was J.J. Thomson. J.J. Thomson. Okay. J.J. Thomson said that a atom is a positive sphere. An atom is a positive sphere in which electrons are spread. In which electrons are spread. Okay. So this electron are negative charge and this sphere is positive charge. Okay. He said that the magnitude of this positive sphere and the electrons are equal, so that makes an atom electrically neutral. This model was proposed by J.J. Thomson. This is also known as plum pudding model because the structure of this atom it looks like a cake which we use mainly in Christmas, like a pudding. Okay, like a pudding. This is basically looks like this cake. That's why this model is also known as plum pudding model. Okay, so after J.J. Thomson structure of atom, Rutherford did an experiment to find out exactly where does the electron, proton or neutron revolve inside an atom. So for that he took a gold foil. He took a gold foil, and on this gold foil it passed a alpha particles. Okay, alpha particles. Okay, then he took a gold foil and he passed an alpha particles through this gold foil. He made three observations based on this experiment. Three observations mainly he saw. He mainly saw three observations, which was first that most of the rays passed that gold foil without deflection. Most of the alpha part rays pass that gold foil without deflection. Okay. Some of the alpha particles. Second observation which he made that some of the alpha particles shows more or less deflection. Some alpha particles shows more or less deflection. Okay, some alpha particles shows the deflection more or less. Okay, and the third observation he made that inside an atom there is a place that when the alpha part rays were going to that place, it rebounded back in the same path. Rebound back in the same path. In the same path. Okay. So the basically three observations were made by the Rutherford. That was the most of the alpha rays were passing the gold foil without any deflection. Some of the alpha particles shows more or less deflection, and the third that there is a particular place inside an atom in which when the alpha rays were going in that part, it was rebounded back in the same path. Okay, so on these three observations, he said that the most of the that the most of the place inside an atom is empty. Most of the place inside an atom is empty because most of the rays were passing without any deflection. So most of the place were empty inside an atom. Okay. Second thing which he said that the in that atom, some in some places there are electrons. There are electrons, because when the alpha particles were striking that electron, they were showing that the deflection, that the only few rays were showing reflection. So on that basis, he said that the in some place there are electrons. And the third thing he said that at the center of an atom there is a part part that is known as nucleus. That is known as nucleus. Okay, but when the alpha rays passed or strike to this nucleus, they were unable to penetrate that nucleus and they were rebounded back. Okay, so on this observation, the structure of atom which we get was like this. An atom is a sphere. In this sphere there is a nucleus. Okay, and the electrons are revolving around this nucleus. This model was proposed by Rutherford. Okay, but there was a drawback of this model. And what was that drawback? That if electrons were revolving, if anything is revolving or moving, then he will dissipate some energy. A time will come when this electron will lose his whole energy. And when he will lose its whole energy, then it will fall at the nucleus. And it will fall at the nucleus. When it will fall at the nucleus, it will make the atom unstable. But in real life, nothing like this happens. So the stability of an atom was not proved by the Rutherford. Okay. So in that place comes Niels Bohr. Niels Bohr said that electrons are revolving around the nucleus, but they are revolving in different energy cells, which are fixed. The number of electrons which will revolve in the energy cells are fixed, which is fixed by a formula that is known as 2n square. Okay, so he said that is it nucleus, and around nucleus there are various energy levels. Okay, and the number of electrons which will be revolved in this energy level are fixed. Okay, so these energy levels are known as K, L, M, and N energy levels. Okay, so the number of electrons which will revolve in K cells or first cells, it is come from this formula. In the place of N, we write that number of that energy cell. So we are talking for first energy cell. So in the place of N, we will write 1. So 1 square, so it will come 2. So the number of electrons which will revolve in the first energy cells are 2. Okay, now the number of electrons which will revolve in second energy cell is 8. So the number of electrons which will revolve in the second energy cell is 8. Okay, okay, just like this, the number of electrons which will revolve in third energy cells, it is 80. Okay, so the number of electrons which will revolve in the third energy cell is it 80, and the number of electrons which will revolve in the fourth energy cell is 32. So the maximum number of electrons which can revolve in the fourth energy cell is 32. So on this basis, the number of electrons which will revolve in different energy cells or different orbit are fixed. It was proposed by Niels Bohr, which was found very accurate. Okay.